Java's collections class is packed with powerful utility methods that simplify working with data structures, but many developers only scratch the surface of what it can do. Did you know there are several lesser known methods in the collections class that can save you time, improve your code efficiency, and solve tricky problems effortlessly? In this video, we will cover some of the hidden methods of the collections class. You will learn how these methods work, when to use them, and how they can level up your Java development skills. So, let's jump in and explore. Suppose you want to create an empty list. This is what you will probably do. Instead, there is a method emptyList in collections class that will create an empty list for you. Remember that this list is an empty list, and you also can't add an element to it. Adding an element will give you unsupported operation exception. So, the question arises, what is the use of this list and method? This method is extremely useful when you have to return a list from a method but the data size is 0. For example, a list of some rows fetched from the database. Instead of returning null, return an empty list to prevent null pointer exceptions. This is also memory efficient as it will return same object every time. But if you return a new array list this way, it will create a new object every time. This is a list of some elements. Suppose I ask you to tell me the frequency or number of times a particular element occurs. Let's say A. You would loop over the list and check if the element matches with the one we want to count and increment a counter like this. Instead of all this, use frequency method in collections class and pass it the list and the element whose frequency we want to know. Print this, run the program. It prints 2, which is equal to the number of times A occurs in the list. If you want to change the order of list elements in random order, then use shuffle method of collections, passing it the list as argument. Shuffle also modifies the original list. Every time you call shuffle, the order of list elements will be random. Run it. Run it again. The order is random. Let's say you want to interchange the position of two elements in the list. Suppose I want to move A to last position and C to first without modifying the other list elements. Collections class has a swap method which can do exactly this. It takes three arguments, the list and the indexes of the elements to be swapped. So, in this case, the first index will be 0 and the second one will be 4, the index of C, since the indexes begin at 0. Run the program. The elements are interchanged. Let's say you want to move list elements by some places. Use rotate method with the number of places the elements need to be moved. So, if I write collections.rotate, supply the list and 2 as the second argument, then it will move all the elements 2 places forward. The elements at the end will be rotated back from the start. This method will modify the original list. So, let's print the list. Run it. Look, all the elements have moved 2 places ahead. Finding minimum and maximum element in a list is a commonly required task. Generally, we write our own logic to do this, and that involves iterating over the list, comparing all the elements with each other, and so on. There is a shorter way using collections class. Collections class has min and max methods which accept a collection argument and return the minimum and maximum element according to the natural ordering. Natural ordering means that if the collection is of numbers, then the min and max elements will be determined by comparing numbers. And if the collection is of string elements, then min and max elements will be determined based on alphabetic comparison. So, collections.min and pass it the list, assign the result to variable. Similarly, collections.max with list argument, assign result to variable, print both of these. Min element should be A and max element should be C. Run it. The result is as expected. Have you ever needed to quickly reset or initialize all elements of a list to a specific value without writing a loop? That's where the collections.fill method comes in. It's a simple yet powerful utility in Java's collections class that allows you to replace all the elements in a list with a single specified value. Fill takes two arguments, the list and the element with which you want to fill. Print the list. Look, all the elements are same. While fill method might seem basic at first glance, it makes all the elements in the list the same. It can save you a lot of time in scenarios like resetting a list, initializing placeholder values, or creating mock data for testing. You can easily reverse list elements with collections.reverse method, passing it the list as argument. Reversing means changing the order of list elements such that the first element becomes the last, second element becomes the second last element, and so on. Remember that reverse method modifies the original list, and this is the reason that the return type of this method is void. Print the list. Run the program. The list elements are in reverse order. When you want an immutable list that cannot be modified and has a single element, then instead of creating a new array list and adding element to it, simply use singletonList method, passing it one element. The singleton list element is more memory efficient than creating an array list for a single element, as it uses a minimal internal structure to store the value. Similarly, there are singleton set and singleton map methods to create an immutable set and map. That is all for today. If you found this video helpful, don't forget to like, share, and subscribe for more tips and tricks to level up your Java skills. And if you have got a favorite hidden method from the collections class, let us know in the comments below. Thanks for watching and see you in the next video.